us take a problem on movements, another model. So in the rocker arm, so rocker arm is a part which is used in vehicles. Shown in figure, the moment of force F about the point O balances that of force P about the same point O. So find F. So he is asking to calculate the force F value. This we have to calculate. Let us solve this problem. See, first we have to calculate this angle. That is, let us say theta. So the angle of this theta and this angle both are same. So let us calculate this angle theta, that is 4, 3. .87 degrees. Now let us calculate angle of P, that is theta P. So the slope given like this. So this is the P 250, this is 4, 3, let this angle is theta P. So theta P equal to tan inverse opposite by adjacent, that is opposite to theta is 3, adjacent to theta is 4, so 3 by 4, and its angle is 36.87 degrees. Now let us calculate this angle theta F. So this slope you can see 2, 1, and this is the angle force. So let this angle is theta F. So theta F equal to opposite by adjacent, that is tan inverse opposite by adjacent, that is 1 by 2. So we are getting this angle as 26.565 degrees. Now we know angle of this force, and we know angle of this force, and we know its angle. So now once we know this theta, so we can calculate these two distances, that is, so we know this total length is 5, this is 5 meters, and this angle is 36.87 degrees. So now this length is 5 cos 36.87 degrees is the horizontal distance, and this is 5 sin 36.87 degrees is the vertical distance. So let us name this point as O, and this point is, let us say, some K, this point is, let us say, some L. So this point is O, K, L. So O, K, L is a triangle, you can see in the diagram. Now let us write the force components, that is, let us write Fx, Fy. So Fx is a component about this line, and Fy is a component about vertical line, this is Fy. So Fx equal to we know its horizontal angle, that is theta f. So theta f is 26.565. So now fx will be f cos 26.565 degrees. Then Fy is a upward force, so that is plus F sin 26.565 degrees. So these are the two components of the force. Now these values are 0.894 F and its value is 0.447 F. Now let us write the moment of the force F with reference to O, that is Fy into its perpendicular distance from O is 0, because this point is O. Then with respect to O, it will create anti-clockwise movement, because the body will be moving in this direction. So that is minus Fx, because this force is towards left side, into its perpendicular distance from O is 6. So now we know the Fx value, that is minus 0.894 F into 6. So this value will be minus 5.364 F. Let this is equation 1. Now let us calculate the components due to P. Components for P, Px, so that is along this direction. This is Px, and in this direction that is a Py. So Px is, we know the angle with horizontal, the angle of P with horizontal, we know that is P is 250 cos 36.87 degrees. So that equal to 0.8 P. Now similarly, we can also calculate Py, that is a component of force P above y-axis, that is 250 sin 36.87 degrees. So its value we are getting as 0.6 P. Now let us write the moment equation for the force P about point O, that is Px into its perpendicular distance KL, that is 5 sin 36.87 degrees. Then Py, so it creates clockwise, so it is plus Py into its perpendicular distance KO, that is 5 cos 36.87 degrees. Now substituting Px, Py values and simplifying the total equation, we are getting final value as 12 100 Newton meter. So this is the equation 2. But in the problem it is given that moment of force F above O balances, means equal to the moment of P. So from the given data, so it is given that equation 1 is equal to equation 2. So equating 1 and 2, that is minus 5.364 F is equal to 1200. Okay. So now we have substituted Px value here, Py value here. We are getting the momentum of P 1200 newtons. So in the problem it is given that equation 1 equal to equation 2, that is moment of force F equal to moment of force P. So equating these two values, we are getting the force F as 223.71 newtons. So this is the answer we are getting. Now the answer is 223.71 newtons. So I'll repeat again. So this is the given rocker arm. First we have to calculate the angle of F with horizontal, angle of P with horizontal, and angle of this line, so that we can calculate this distance and this distance. Write the components Fx, Fy, calculate, and write the components Px, Py, calculate, and write moment equation for force F. We are getting equation 1. Write the moment equation for force P, and we are getting moment, that is the moment we are getting as a 1200 newtons. Now equating 1 and 2, that is 1 is the minus 5.364 F and equation 2 is 1200 newtons. So from this we are getting the force value as 223.7 newtons, and this is the answer.